Hello and welcome to our Spring Symposium 2023 presentation. We are Team Aerocyonics, and this is our project, the SAINT Dashboard, the Security Articles of Interest for Awareness, Outreach, and Actionable Intelligence. Let's meet our technical directors for this project. We have Daniel DeMays, President and CEO of Aerocyonics. He is also a URI alumni, class of '89. Next is our director, Bron Pav, Chief Engineer at Aerocyonics. We want to thank them both for their help and support throughout this entire project. Now let's meet the team. I'm Bella Johnson, computer engineering major, and my other team member is James McDermott, computer engineering also. A little bit about Aerocyonics. They are headquartered in East Greenwich, Rhode Island. They aim to provide expertise in technology sectors such as cyber-physical system security, hardware and software assurance, counterfeit avoidance and detection, and the advancement of talent in topic areas. This project motivation stems from the issue of cybersecurity, which is the art of protecting networks, devices, and data from unauthorized access or criminal use, the practice of ensuring confidentiality, integrity, and availability of information, as well as confidentiality, integrity, and availability of people, process, and technology across a distributed supply chain. Why is cybersecurity important? It's important because it affects every industry, organization, business, and user who's online. In our increasingly digital world, there's a growing volume and sophistication of cyber attacks. This brings us to the weekly security articles of interest, a current service provided by Aerocyonics. In this service, a document roughly 150 pages is sent out to their subscribers every week with links to information about the most current cybersecurity news.
The anticipated best outcome for this project was to gather actionable intelligence on the threats provided in the articles of interest. We wanted to be able to provide the users with mitigations for the security threats. In order to do this, we had to utilize natural language processing and deep neural networks. Also, part of the anticipated best outcome was to bring the project up to TRL level 6, which we successfully did. It was important for this project to make the software scalable, so that way it could be cost scalable. In other words, there could be a free option and a subscription option. Also, it would be very important for companies for the software to be searchable. So that way they don't have to look at all the articles of interest, but only the ones that pertain to them. So for our project planning, we first developed our Gantt chart, which laid out the schedule for our project and provided us with milestones so we can know if we're staying on task or not. We met with Bron weekly to provide him with progress updates, and we met with Dan monthly to quarterly and would do a quad chart presentation for him to catch him up to speed on what was getting done on the project. There was a lot of big challenges in this project, so we had to break it up into smaller tasks. So Bella and I decided to work on functions separately and make sure our software was modular. So that way we can then combine all of our functions and have a working software in the end. This is the UML diagram for our project, which goes from step 1 all the way to the end. I'm going to be going through this in the upcoming slides. So the first step was to read the PDF file. The PDF file I'm talking about is the one that Dan would send us in an email. It was the weekly security items, and on that was the articles of interest and the URLs for the articles of interest, which is what we were interested in. So after pulling the PDF file into our code, we needed to perform text sanitation on it. And what that means is we scraped off all the other text other than the URLs. And we compiled the URLs into a list so that way it could be passed on to the next function. The next function would then cycle through all the URLs and look them up and extract the text from the website. Once the text was extracted from the website, we had another function called frequency analysis. And what that would do is it would count keyword occurrences. Which keywords? The ones that are correlated with the threat type. So if you look at the columns in the Excel sheet that you see on this slide, the one all the way to the left, electronic and physical security, if you just look below that, you will see numbers. Those numbers are keyword occurrences. So we had keywords that were correlated to that column, and the amount is the number. And that would tell us where the article should be categorized. And then obviously we exported it to Excel, but later we will export it to our web GUI. This was just a temporary thing to display our results. So this is our final taxonomy. If you look underneath the top level categories, like reconnaissance, for an example, all the way to the left, underneath that are all threat types. So this is what the articles are going to be categorized by. So we needed to come up with keywords for every single one of these and greatly expand our taxonomy. We used the smaller taxonomy at first just to get a proof of concept to make sure our software was functioning. So the machine learning part of this project, we needed to create labels for the articles. The labels were the threat types that you just seen on the previous slide. So we would label the article with, let's say, the threat that article pertains to, and then store it in our machine learning model. Eventually, after we build it up enough, so we provide a good sample for it, it will be able to categorize the articles on its own, and we wouldn't have to do so. So obviously we have a ton of threat types, so we need to automate this approach. So that's where frequency analysis came in, because this can basically label the article for us, which saves us a ton of time. So this automated the process of building the sample for our machine learning model. It was important that we had a WebUI for this project, so the users could sign in, see all the articles of interest, see what threat types pertain to them, and then get mitigations for those threats. So I looked on the web and I found an open source web UI called Cubic on GitHub. And it was perfect because it utilizes Python and Flask, which is perfect for our project since we wrote it in Python. All we had to do is download Docker and Ubuntu to load this up and edit the HTML files to display what we wanted to display. And the final challenge of this project was to get the mitigations. So my method for doing this was to scrape all the mitigations and bring them into the code. If you look at the database on the left, like I said before, underneath reconnaissance, they are active scan and gather victim host information. Those are all the threats. If you click on those, this database actually has a mitigation on the page that it links to. So by utilizing the same method that I did for the PDF file, text sanitation, I scraped everything off, minus the mitigation, and then stored it into our code. Because our articles of interest were already categorized into these threat types, I could then connect the mitigation to the threat type, which is then connected to the article. And now I'll pass it over to Bella.
Now I'm going to go over the parts of the program I worked on. The programs I worked on were the frequency analysis, natural language processing, Excel, mitigations, and web user interface programs. An important feature of the SAINT tool is a complex taxonomy. We resembled our taxonomy from the MITRE ATT&CK database, where there were top-level categories such as resource development and subcategories within that domain of interest. I worked to actually expand the taxonomy by using AI tools to find keywords that best fit each category. You can see on the right is lists of keywords for a top-tier category, resource development, along with some of its subcategories like compromised accounts and compromised infrastructure. Once I had the list of keywords for every category in our taxonomy, I ran our frequency analysis program, which takes an article and finds the amount of occurrences of each keyword in that article. Depending on the result of our frequency analysis program, we can determine the top tier categories for a specific article, and from there find the subcategories by performing frequency analysis again with the keywords of the subcategories. This frequency analysis program is an efficient and accurate way to organize articles into the taxonomy. I also worked on our natural language processing algorithm. I utilized an NLP library that specializes in dealing with large texts. I first used the NLP library to process the text of an article, which means that the text was stripped of any punctuation, pronouns, or stop words. Stop words are words that do not contribute to the content of an article. So given a text of a new article and the text of a sorted article, we then perform a calculation to find the similarity between those two texts. If the articles are similar enough, we know that the sorted articles category also works for the unsorted article. This natural language processing program works accurately to group new articles into categories, but the runtime is extensive due to the amount of articles in our database that need to be compared. Lastly, I worked on the web user interface to include all of our data and results, as well as the Aerocyonics logo and information. You can see on the left is a screenshot of our UI with a table of all our articles listed with their release date, their category, industry. Eventually we'll have industry filled in, mitigations, and source. I was also able to create charts that display the trend analysis for the week, as displayed on the right, which will be an important feature of the SAINT tool. Now here is a full demo of the working SAINT tool. You can see on the left, we can click current AOI, which shows the articles for the current week. We also have a library page with every past article. Also, a radar chart shows the distribution of threat trends for the week. And we also have that information in a bar chart and pie chart. Lastly, I want to thank all the people who made this project possible. Dr. Sunak, our Capstone Program Director, Brendan and Jamie, our Consulting Technical Directors, and Dan and Bron, our Directors from Aerocyonics. Thank you.